have Agnes from TARI Seaweed in the Faroe Islands. Agnes is the co-founder and the owner of the company TARI, but she also has a scientific background, and she works as a part-time researcher for Fiskaling, which is the aquaculture research facility in the Faroe Islands. I hope I pronounced that right, Agnes. Feel free to share your screen there. Agnes will talk to you all about the practical side of setting up a hatchery and the elements that are required to do so.
Yeah, can you all hear me?
Yes.
Yeah, so thank you very much for the introduction, Cleona. And yes, I am Agnes Mortensen. I come from the Faroe Islands, and I run and own half of the company called TARI Faroe Seaweed, which is a seaweed producing and processing company, of course, based in the Faroe Islands. And I am going to talk about, well, we call it the fundamentals of setting up a hatchery, and it will be very much from a practical perspective, and, you know, maybe a bit of my own journey through the building up hatchery skills and stuff like that. But I would like to start with introducing the company a little bit, so you know what we're doing. So we try to do what we can to be biologically sustainable, and we run a production of aiming for the best quality of seaweed, and we make some food products, and we work a little bit with feed also. And then we have a third product that we call lumpfish shelters. So this is a fairly new product that we seed these structures with seaweed, and they are sold to the salmon aquaculture industry to apply in the cages with the salmon, because they use lumpfish as cleaner fish to eat the salmon lice of the salmon. And these lumpfish, they need something to thrive in, so shelters, so they will their livelihood will be better. And so we sell these structures also. So we are a little bit broad in our approach. We have a hatchery license, and this is our current hatchery. I will talk more about hatcheries all through the talk. And we also have a farm that is sea-based. We primarily work with the Alaria esculenta, that's our main crop, and we also work with Saccharina latissima, and we do a little bit, so those are the two types that we produce on the farm and in the hatchery. We will go into production of, or at least experiments with Palmaria palmata, but that will be in tanks on land, and I will touch in on it a bit later. So we are a part of the SW Grow project that is presented here today, and our part in this project is to work with cultivation and quality improvement. So far we are focused very much on looking at improving or optimizing the quality of our crop on the farm, and we do that by looking at trying to understand the natural conditions on the farm. So we're trying to take samples and look at what the natural environment has to offer, and when our production fits best into the natural environment. And in that way, the idea is to work sustainably with the natural environment on the farm, and in that way also to get the very best seaweed quality out of that production. So enough of introduction, I will go into the hatchery part. So the fundamental of cultivating seaweed or cultivating anything is to understand the life history. And this is a drawing of the life history of Alaria esculenta, which is one of the kelp species. And the other kelp species will have a very similar life history to Alaria. So if I just take the pointer, so here we have the sporophyte. I'm sure a lot of you know all about this, but we were going for the fundamentals, so I thought I would include it. So the sporophyte is the stage that we know from the shore. That is the stage in the life cycle that produces spores. So the spores are produced on these small blades down at the stipe. And here you zoom in and make a transverse cut through the small leaf here, and we have the sporangia that produce the spores. The spores, when they are mature, they are released from the sporangia, and half of them will develop into male individuals and half of them into female individuals. So these are the gametophytes, and the gametophytes become fertile if given the right conditions. And after and when they are ready, the male gametes, they are released and they are able to swim, so they will go out and fertilize the female gamete, which is sessile. And after that fertilization, the new generation starts growing, and that is the new sporophyte coming up here. So that's the basic life history that you have to deal with when you want to cultivate seaweed. So in a hatchery, you can work with different stages. So you can seed your substrate with spores, or you can seed them with what I here call microsporophytes, which refer to these immature new sporophytes. So they are just tiny, and they are, if you keep them in cultures, if you look in the microscope, you will have a mix of, we'll have the gametophyte stage, and then you will see these small structures of new sporophytes, just a few cells big, coming out. And so if we talk first about seeding with spores, you can see an example here. So these ropes are seeded with spores. And then you will have the entire life history going from the spore to the new sporophyte growing up. That will happen on the rope that you will later deploy into the ocean or the sea. And that means that the individuals, the seaweed sitting on the rope, sticks really well to the substrate because they have been developing there. This method is, however, space demanding. And that can be something to think about in an upscaling process. And selection is not, it's difficult to work with selection using spores because you won't be having the male and female individuals that you can cross. And then we can work with seeding with microsporophyte cultures. That means you will have to, so you will take the spores, you will release them, and instead of releasing them onto substrate like up here, you will release them into culture flasks, and then you will give the cultures conditions so that they will develop into these microsporophytes. And then you can seed the microsporophyte cultures. You can choose to seed them non-direct. That means you are seeding those cultures, the microsporophyte culture, on the substrate like you did up here with the spores. Then you will give them time to stick onto the rope as with the spores before deploying. But if you choose to do that, you will still need a lot of space because you will be bringing the substrate into the hatchery. But using this method, it's easier to work with selection. And then you can choose to work with direct seeding. That means you take the sporophyte or the microsporophyte culture and you spray it onto the substratum right before you deploy. Then you are in a situation where the culture may not stick very well to your substrate when you deploy. You may lose a lot of individuals. But the advantage with this method is that you work only in flasks. You do not bring in your substrate into the hatchery, so you won't be needing the same space. And selection is again also possible here. So there are different ways to do this, to work with the life history. Basically, setting up a basic hatchery is not, it doesn't have to be very high tech, but there are a few things that are necessary. So you have to work with cleaned seawater, and you can clean it by filtering and UV treating, and that's probably the normal way to do it. It's important to have fairly clean water, and especially to try and get rid of other algae, because if you bring other algae into your cultures or your tanks, then they can compete with the crop you really want to grow. So that's important. Light is of course also important for the photosynthesis process, and I think by now most people are using LED light, so to save energy. Nutrients, they are of course also really important. That's how the seaweeds are growing. And when you work in a system with flow-through tanks, you will get the nutrients from the natural environment where you'll be pumping your seawater in from. But working with cultures, you will have to provide nutrients, extra nutrients, and that's something to consider, you know, with regard to sustainability and with regard to if you're producing organically. So you have to be careful which nutrients you choose. And then temperature is also really important, because there are stages in the life history where temperature can be critical for the life history to develop. And an easy way to go about that is to work to fit your hatchery season into when the temperature outside and the seawater temperature outside is at the right level, and especially if you work with flow-through tanks, then you will pretty much be dealing with the temperatures that are outside at that given time. If you work with cultures, then it's more easy to maybe establish a room where you can control the temperature. So I will be moving now into my practical experience going back all the way to 2005. That's when we did the very first experiment with cultivating seaweeds here in the Faroe Islands. At that time, I was a student at the university in Copenhagen, and we managed to get some funding from NORA to run an experiment with cultivating Alaria esculenta. And the idea we had at that time was that we wanted to cultivate seaweed because we wanted to grow seaweeds in close to all the salmon aquaculture that was going on in the Faroes to take up excess nutrients. We never got that far because the aquaculture people weren't interested in having us close by, but at least we managed to do an experiment in the hatchery and also to actually deploy the ropes that we had seeded. So you can see that this is an extremely simple setup of a hatchery. We have the fluorescent light up here. That was before LED became modern. And then we have the substrate, two types of substrate in our tanks. We worked with, these were of course not flow-through tanks. We just put in enough seawater that we had manually filtered. And then we added nutrients, and the conditions that we gave the hatchery were light intensity of 20 microeinstein. We had a light-dark interval of 16 hours of light and 8 hours of darkness every day. And we managed to have the temperature at around 8 degrees Celsius, and that was due to the outside temperature that we could stabilize it there. And we added nutrients once or twice, I think twice. And this experiment went on for 1 month, and then we deployed our ropes. After this initial, well, I have to add to the story that we had no practical experience back in 2005, but there were papers coming out from the Martin Ryan Institute in Galway. And we got help from people there. So Stefan Kran and his co-workers, we invited 2 guys to come to the Faroes and help us set up this system. So that was, you know, a really nice input that we had from Ireland back in 2005. I came back to the Faroes when I after finishing my master thesis in Copenhagen, and I tried to repeat the same experiment again, just to see if I could do it again. This was very, very exciting things for me to do back then. And I was living in my hometown, and I borrowed a corner of a storage room in the local fish factory. And I just had this tank with light on top of it. And looking down into the tank, you can see I had a bit of rope, and I had 2 of those boxes. And I used basically the same conditions as we had done the couple of years before. So after 1 month, this was how the ropes looked like. And when I looked in the microscope, you see really, really nice sporophytes of Alaria esculenta. Those were again deployed, and just to give an impression of the development, this is when we deployed in December 2007, and in January there were small dots visible on the rope, and this was from February and March and April, and then later again in April. So the crop had grown quite fast and it worked quite well. So this was really encouraging at that time. And we, the world was slowly moving, and we could see that, we need more space, we need better conditions to build the hatchery and develop this industry, or trying to, develop something commercial. So we got in touch with a marine station that was owned by Fiskealing, and they were running experiments with lumpfish. So they were trying to produce lumpfish there. And we were able to set up a small hatchery in their attic there. And the good thing with being there was that we got access to clean seawater. So we didn't have to, hand filter and do all kinds of things to it. We were still not working in a flow-through system, but we had much larger tanks where we could just change the water on like a daily basis or something like that. And we also started doing experiments with developing the life history in culture flasks. And so that was really exciting, and it was, we were trying to bring ourselves forward in the macroalgal cultivation world. And we had, this is one batch of Saccharina latissima sporophyte culture that we actually used for direct seeding. Direct seeding, as I mentioned before, is when you take your culture and you spray it on or add it to your ropes, and then a little bit later you deploy them. We actually managed to get really nice results from this method, but we also experienced really, really bad results with almost no growth at all, where all our culture had just been washed off. This was before people started using, or around the time when you started being able to buy commercial glue products. So we decided not to go down that lane, because we had actually gotten to the point where we had demand for both food products and also for the lumpfish shelters. So we decided to try and find a solution that was safe and worked every time. And we invested in our current hatchery, which is in a large container. It's situated outside the same marine station as we were inside before. So we're still using their clean seawater, but we primarily work with spore seeding. So we do not work very much with cultures, and the reason is basically because we don't have the space. We only have one room, so we kind of work in the very basic and very safe way at the moment. We are, however, growing out of this hatchery also, and the next step is going to be that we are moving from this location here in the north to a location on the southern island, where we will be situated in a small village on the west coast. We have chosen this particular place because it is very close to very high quality seawater that we can pump in. We have, and we are also very far away from all aquaculture, salmon aquaculture activities, because we are also trying to limit, getting salmon diseases into our hatchery, because we are selling to most aquaculture sites in the Faroes, these lumpfish shelters. So, and in this location, we are also actively working on the pilot that Andrew was mentioning on cultivation. So we are building, or we are establishing a hatchery that is run on renewable energy. So we are installing a turbine in this building, and the reservoir, the water reservoir that is feeding into the turbine, is situated on top of the mountain up here. And it runs down to some pipes into our building. So this new hatchery will be, it will have both space for flow-through tanks. It will also have space for keeping cultures. So we are getting ourselves ready for the next stage, as Antoine was talking about, with going into selection and improving yield and probably other characters as well in the future. And we want to do that all with being based on renewable energy. And another add-on in the hatchery, hopefully soon, will be that we will run experiments with tank cultivation of Palmaria palmata, and a commercially very interesting species. And we can of course do that because we will have renewable energy, and that could be a feasible way to actually produce Palmaria in a sustainable way. So that was all from me.
Perfect timing, exactly within the 20 minutes. Thank you very much. That was very, very interesting. I think it had some practical tips to those of you in the audience who's looking to set up a hatchery. And Agnes is fantastic. She's very approachable. So if anyone has any questions, feel free to contact her.